So this is Module 3, Topic 3 in the workbook, and it's not covered in the OLI textbook, but other books that I've used, the book by Triola for one, they do cover this right around at the same time when they're talking about the different types of variables. So it's brief, it's only 7 slides, and so here we go. Start the slideshow over here. Okay. So, and the idea is that some measurements are better than others. A categorical or qualitative variable might be measured at either one of 2 levels, nominal or ordinal. And a numerical or quantitative variable might be measured also at either one of 2 levels, the difference or ratio levels. And the ratio level is better. And these levels of measurement will be described in more detail in the following slides. So, I want to start by comparing the ordinal level with the nominal. Now, the nominal level does not allow for comparison. There's no natural order to the names of the categories. So, if the individuals in your population are glasses of cola, and you're measuring this categorical variable, the brand of the cola, the names might be Coke, Pepsi, and Red Bull, but these don't come in any natural order. You might like one better than the other, but there's no, like, A is greater than B built into the system of names. But here's another categorical variable that you could measure. This would be the size of the glass, and the names of the categories might be small, medium, and large. Now, these categories do have a natural order. So even though you don't know how much cola is in a small glass, you can still compare which one is more. And so there's an order to it. This is a measurement at the ordinal level. Sometimes if you're ever in the hospital or you go to a doctor's office, they might ask you to rate your level of pain on a scale from 1 to 10. See, that's a categorical variable because even though the names of the categories are numbers, it's not really an amount of anything. It's kind of a fake numerical variable. They could have just as easily used A, B, C, D, E instead of 1, 2, 3, 4, 5. So that one, it's a categorical variable, but it's an ordinal level of measurement because you can tell, okay, if one day it was a 2 and then the next day it's a 3, that's more pain on the second day. Okay. Now, I want to compare the ratio level with the difference level. A measurement at the difference level doesn't have a meaningful 0. A temperature of 0 degrees Fahrenheit does not mean no temperature. And the temperature of 4 degrees is not twice as hot as 2 degrees because you started counting from an arbitrary place. But differences do have a meaning. A change of 4 degrees is really twice as much difference as a change of 2 degrees. So subtracting 2 temperatures gives you a number where 0 really means 0, But the temperatures themselves don't have that property. So this is a measurement at the difference level, or you also may call that the interval level of measurement. Now, measurement at the ratio level does have a meaningful zero. You might measure the weight of a stone in pounds. The number 0 really means no weight. 4 pounds really is twice as heavy as 2 pounds. So not only do the differences mean something, but the ratios also mean something. So the ratio level of measurement is a higher quality than the difference or interval level of measurement. So here's a chart of the levels of measurement with the nominal level at the lowest quality. And then the ordinal is better, and the interval is better than that, and the ratio is the best. They have some examples here in the chart. For nominal variables, you might have the type of a car that you own, or marital status. Whereas ordinals would be, well, like they're these stock ratings. It says Standard & Poor's here, bond rating. You may be more familiar with like Morningstar ratings, where you get 1 star, 2 stars, or these star ratings for restaurants, or letter grades. If you don't know more details about an instructor's grading system, then all you know is, okay, an A is better than a B, but you don't really know how good is that. Interval level of measurement would apply to temperatures in Fahrenheit, standardized exam scores, you know, a number that you get on the SAT. And then ratio, height, age, amount of money you spend on food. One they did not mention here, if you do temperature in degrees Kelvin instead of Fahrenheit, then the 0 really does mean 0. So it's the same variable, temperature, but it can be measured with 2 different levels of quality, depending how you set up the system for recording the values. That's all for this topic.